Managing uncooperative suppliers is a crucial aspect of running a successful electrical contracting business. Here's how to navigate those challenging situations. Firstly, establish clear communication. Discuss the project specifications thoroughly with the supplier and put everything in writing. State the exact parts and materials required, including brand, model, and quantity. Provide a detailed list of the items you are responsible for and those the owner is supplying. Secondly, verify orders and invoices. Double-check all orders and invoices against your original specifications. If there are discrepancies, contact the supplier immediately to correct them. Keep a record of all communication and documents related to the order. Thirdly, monitor deliverers. Inspect deliveries upon arrival to ensure they match your specifications. Note any missing or damaged items and report them to the supplier promptly. Document the time and date of delivery for future reference. Fourthly, document all interactions. Keep a record of all conversations, emails, and other communications with the supplier. Note any concerns, discrepancies, or attempts by the supplier to mislead or overcharge. Fifthly, seek support. If you are unable to resolve issues directly with the supplier, contact your local contractor association or licensing board for support. They may provide guidance or mediate disputes. Sixthly, consider changing suppliers. If the supplier continues to be uncooperative or deliberately sabotages your projects, consider finding an alternative source. Get recommendations from other contractors or check online reviews. To prevent future issues, take these steps. Establish relationships. Build positive relationships with reputable suppliers who are knowledgeable about your industry. Review supplier policies. Familiarize yourself with each supplier's policies regarding returns, credits, and dispute resolution. Read contracts carefully. Pay attention to the terms and conditions of any agreements you enter into with suppliers. Use online ordering. Consider using online platforms that provide transparency and accountability in the ordering process. If necessary, seek legal advice. Consult with an attorney to protect your interests and enforce your contracts. Remember, it is crucial to maintain professionalism and integrity in your dealings with suppliers. By following these strategies, you can minimize the impact of uncooperative suppliers and ensure the success of your project. Consider the typical electrical service for a residential dwelling. According to the National Electrical Code, NEC, the service size must be adequate for the calculated load. This involves determining the total connected load of all electrical devices and appliances in a house. The NEC provides guidelines in Article 220 for calculating these loads. For example, general lighting load is calculated based on the square footage of the dwelling. Small appliance circuits and laundry circuits are required to be included at 1500 volt amps each. Fixed appliances like water heaters, ranges, and air conditioners are calculated at their nameplate rating. After calculating the total connected load, demand factors can be applied to account for the fact that not all devices will be operating simultaneously. Demand factors are specified in the NEC and vary depending on the type of load and the number of appliances. Once the final calculated load is determined, the service size can be selected based on the ampacity of the service conductors and the overcurrent protection device, typically a circuit breaker or fuses. The service conductors must have an ampacity equal to or greater than the calculated load. The overcurrent protection device must have a rating equal to or greater than the calculated load, but not greater than the ampacity of the service conductor. Common residential service sizes are 100 amps, 150 amps, and 200 amps. For a 2400 square foot house, a 200 amp service is often adequate, especially if there are numerous electrical appliances and a central air conditioning system. The panel board selected should have sufficient spaces for all the required circuits. A 40-circuit panel is often a good choice for a house of that size, allowing for future expansion. When ordering electrical parts, it's important to specify the exact items needed, including the manufacturer, model number, and quantity. This helps to avoid confusion and ensures that the correct parts are delivered. If substitutions are made, they should be approved by you before the order is processed. When receiving deliveries, inspect the items carefully to ensure that they match the order and that they are not damaged. Any discrepancies or damage should be noted on the delivery receipt and reported to the supplier immediately. Keeping accurate records of all orders, invoices, and deliveries is essential for managing costs and resolving any disputes. It's also important to have a good working relationship with the supplier. Building trust and open communication can help to avoid misunderstandings and ensure that you receive the best possible service. If you encounter problems with a supplier, try to resolve them amicably. If that's not possible, consider switching to a different supplier. There are many reputable electrical suppliers to choose from, so it's worth shopping around to find one that meets your needs. Remember to document everything, as you are already doing, because that is your protection to solve issues easier. Now let's discuss specific electrical components in more detail. Considering the panel board, it serves as the central distribution point for electrical power in a building. It receives power from the service entrance and distributes it to various branch circuits throughout the building. Panel boards are typically rated for 120/240 volts single phase or 208/120 volts or 480/277 volts three phase. The rating should match the voltage of the electrical service. Panel boards consist of a metal enclosure, a bus bar assembly, and circuit breakers or fuses. The bus bars are conductive strips that distribute power from the service entrance to the circuit breakers. Circuit breakers are overcurrent protection devices that are designed to trip and interrupt the flow of current in the event of an overload or short circuit. Fuses serve the same purpose as circuit breakers, but they are one-time use devices that must be replaced after they blow. Panel boards are available in a variety of sizes, ranging from small panels with a few circuits to large panels with hundreds of circuits. The size of the panel board should be selected based on the number of circuits required and the anticipated future load growth. When installing a panel board, it's important to follow the manufacturer's instructions and all applicable electrical codes. The panel board should be mounted securely to a wall or other support structure. The wiring should be neat and organized, and all connections should be tight. Grounding is also an important consideration. The panel board should be properly grounded to provide a path for fault current to flow back to the source, which helps to protect against electrical shock. Regarding circuit breakers, they are essential safety devices that protect electrical circuits from overloads and short circuits. Circuit breakers are designed to trip and interrupt the flow of current when the current exceeds a certain level. This helps to prevent damage to wiring and equipment, and it also reduces the risk of electrical fires. Circuit breakers are available in a variety of sizes and types. The size of a circuit breaker is determined by its ampacity rating, which is the maximum amount of current that it can carry without tripping. Circuit breakers are also available in different trip characteristics, which determine how quickly they will trip in response to an overload or short circuit. Common types of circuit breakers include thermal-magnetic circuit breakers, which use a bimetallic strip and an electromagnet to trip the breaker, and electronic circuit breakers, which use electronic sensors and circuits to trip the breaker. When selecting a circuit breaker, it's important to choose the correct size and type for the application. The circuit breaker should be sized to protect the wiring and equipment that it serves. It should also have a trip characteristic that is appropriate for the type of load that it serves. When installing a circuit breaker, it's important to follow the manufacturer's instructions and all applicable electrical codes. The circuit breaker should be installed in a panel board that is properly grounded. The wiring should be neat and organized, and all connections should be tight. Now let's look at conductors, which are the wires that carry electrical current from the panel board to the various devices and appliances in the building. Conductors are typically made of copper or aluminum. Copper is a better conductor of electricity than aluminum, but it is also more expensive. Aluminum conductors are often used in larger sizes to save money. Conductors are available in a variety of sizes, which are specified by their American wire gauge, AUG, number. The larger the AWG number, the smaller the conductor. The size of the conductor should be selected based on the amount of current that it will carry and the distance that it will travel. The NEC provides tables that specify the ampacity of different sizes of conductors. When selecting a conductor, it's important to choose the correct size and type for the application. The conductor should be sized to carry the expected load without overheating. It should also be insulated to protect against electrical shock. Common types of insulation include thermoplastic high heat resistant nylon coated THHN and cross-linked polyethylene XLP. When installing conductors, it's important to follow the manufacturer's instructions and all applicable electrical codes. The conductors should be installed in a raceway, such as conduit or cable tray, to protect them from damage. The wiring should be neat and organized, and all connections should be tight. Grounding conductors are also important. These conductors provide a path for fault current to flow back to the source, which helps to protect against electrical shock. Now let's talk about grounding, which is an essential safety measure that helps to protect against electrical shock. Grounding provides a low impedance path for fault current to flow back to the source, which causes the overcurrent protection device to trip and interrupt the flow of current. This helps to prevent electrical shock and reduces the risk of electrical fires. Grounding is achieved by connecting the metal enclosures of electrical equipment to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a connection to the earth, which helps to dissipate fault current. The NEC specifies the requirements for grounding electrical systems. These requirements include the size and type of grounding conductors, the type of grounding electrodes, and the methods of connecting the grounding conductors to the grounding electrodes. When installing a grounding system, it's important to follow the NEC requirements and the manufacturer's instructions. The grounding system should be inspected regularly to ensure that it is in good condition. Now for a brief note on overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when the current in a circuit exceeds the rated ampacity of the wiring. Short circuits occur when there is a low resistance path between two conductors. Overcurrent protection devices are designed to trip and interrupt the flow of current when an overload or short circuit occurs. This helps to prevent damage to wiring and equipment, and it also reduces the risk of electrical fires. Circuit breakers are resettable devices that can be reset after they trip. Fuses are one-time use devices that must be replaced after they blow. When selecting an overcurrent protection device, it's important to choose the correct size and type for the application. The overcurrent protection device should be sized to protect the wiring and equipment that it serves. It should also have a trip characteristic that is appropriate for the type of load that it serves. Finally, I'll talk about electrical boxes. Electrical boxes are enclosures that are used to protect electrical connections. Electrical boxes are available in a variety of sizes and shapes. They are typically made of metal or plastic. Electrical boxes are used to enclose wiring splices, receptacles, switches, and other electrical devices. When installing electrical boxes, it's important to follow the NEC requirements and the manufacturer's instructions. The electrical boxes should be securely mounted to a wall or other support structure. The wiring should be neat and organized, and all connections should be tight. Electrical boxes must be sized appropriately for the number of conductors and devices that they contain. The NEC specifies the minimum size requirements for electrical boxes. In summary, dealing with difficult suppliers requires clear communication, thorough documentation, and a willingness to seek support or change suppliers if necessary. Preventing future issues involves building strong relationships with reputable suppliers, understanding their policies, and carefully reviewing contracts. Electrical installations must comply with the NEC and involve proper sizing and installation of panel boards, circuit breakers, conductors, grounding systems, and electrical boxes. Adhering to these guidelines helps ensure the safety and success of electrical projects.